Right, so we're going to finish up trig identities today looking at the last group, which is called the Pythagorean Identities. And now, just because we're learning the Pythagorean identities, that doesn't mean every single problem is going to use what I'm about to show you. Some problems on the test might just be what you learned yesterday. Some might also include some of what we're learning today. Okay, and the first identity says sine squared plus cosine squared equals 1. Okay, and I'll show you that one on the calculator. I'll do it with a specific example. Okay, Peter, can you give me an angle? Any angle you want?
35.
35. So, were you in radians or degrees?
Degrees.
Degrees, okay. So I'm going to switch to degrees. And I'm going to plug 35 in for theta. So I'm going to take the sine of 35 and square it. That's how I have to type it in on the calculator. Plus, I'm going to take the cosine of 35 and square it. And according to the formula, when I hit enter, what should I get? 1. And you do. So no matter what you plug in for theta, it would always be 1. So that's kind of nice. If you get a formula that has all that stuff in it, sine squared plus cosine squared, you can cross it all out and just write 1. Okay, so that's one of them. All right, let's... Okay, this part, I just want you to watch this part because I'm going to write the result in a second. But I'm going to take everything in that identity and I'm going to divide it by sine squared. And again, just watch this. And when you simplify that, that's the next identity. What's sine squared divided by sine squared? If you had sine squared divided by sine, it would be sine. But if you have sine squared over sine squared, 1. You're dividing two things that are the same. What about cosine squared over sine squared? We know what cosine over sine is. So what do you think cosine squared over sine squared is?
Cotangent squared.
Yep, cotangent squared equals... And now, can somebody remind me, what's 1 over sine? Yep.
Cosecant.
Cosecant. So what do you think 1 over sine squared is?
Cosecant squared.
Cosecant squared. Okay. And that's the second Pythagorean identity. So it's the second one is really just the first one, dividing everything by sine squared. Okay. And to get the third one, I'm not going to divide everything by sine squared. Any guess what I would do to get the third one? I'm still going to divide everything by something. By what?
Cosine.
Cosine squared. Okay. Okay, so again, just watch this part, and we're going to write the result right here. All right, so we know sine over cosine is tangent. So what do you think sine squared over cosine squared is? Yeah.
Tangent squared.
Tangent squared. Plus cosine squared divided by cosine squared. Dividing two things that are the same. 1. Equals. And what about 1 divided by cosine squared?
Secant squared.
Secant squared, yeah. Because 1 over cosine is secant. So 1 over cosine squared is secant squared. Okay, and those are the 3 Pythagorean identities. So really, if you can only remember the first one, you can always figure out the other 2 from the first one. Okay. Any questions on those? And those identities pretty much work with those powers. You can't change like the 2's to 3's. You can't say sine cubed plus cosine cubed equals 1. No, that doesn't work. Okay, you can only do it like that. with those powers. Now, what if I did this? I'm going to subtract something from each side. And I'm going to write cosine squared equals 1 minus sine squared. Is that a new identity? Cosine squared equals 1 minus sine squared. What do you think? Well, let's look at this formula. Have people seen that before? Distance equals rate times time? All right. How would I get r by itself in that formula? What would I do? Yeah, I would divide each side by t. Okay, so this is what I started with. I'm going to divide each side by t. And now I have d over t equals r. Is that a different formula from the one above? No. It's the same formula rearranged. That's all. You just move some things around. So if I go back here and ask the same question, is what I've written in red, is that a different formula? What do you think, Emma? No. It's not a different formula. It's the same formula, just moving things around. So you can take any one of these formulas and rearrange it. Like you could do a -1 in the second identity and move it to the other side. Right? So you have to look for that sometimes. Okay? You have to look for an identity, but it might be rearranged a little bit, just like that formula can be rearranged. Okay? All right, so some of the problems we're going to see today are going to say verify, some are going to say simplify. The difference is verify is what you did in the homework last night. Verify means here's what you start with, here's the answer. Show me how to get there. Okay, most people like verify better because they already know what the answer is going to be. They just have to figure out how to get there. Okay, simplify is a little harder. If I had something, I don't know if I have any simplifies today. No. But yesterday in the notes we did simplify. Well, simplify is kind of open-ended. All simplify means is you get a problem and you do as much work as you can until you think you're done. Okay, with simplify you don't know when you're done. Yeah?
I'm supposed to say when we are asked to verify?
When we are. It does. Thank you. Yeah. So when we are asked to verify, that means take the left side, usually the left side, and simplify it until you turn it into the right side, till they're the same. Okay, so here's an example of a verify. You've got a left-hand side, you've got a right-hand side. You have to turn one into the other. My suggestion is always start with the side that looks more complicated. I think here, the left side, definitely more complicated. Left side, more complicated. Which side is more complicated here? The left. It's a lot easier to take something that's complicated and simplify it than it is to take something that's already simplified and try to complicate it. But that's a lot harder to do. Okay, so your goal is to simplify one side so that it looks the same as the other, just like you did in the homework. And start with the more complicated side. If both sides look like they're about the same level of complication, then start with any side you want. But what I would always do is pick one side to work with and don't mess with the other side. Sometimes when people do trig identities, they try changing both sides at the same time. You can, but some people get confused doing that. So leave one side alone, play with the other side. Okay, any questions on that? Okay, so really, as far as formulas, you're going to need the Pythagorean identities, the reciprocal, and the quotient. All right, so verify. So sine times cosecant minus cosine squared is somehow going to come out to sine squared. So, I think I already said it earlier, but which side do people think is more complicated here? The left. Okay, so we're going to start with the left-hand side, and we're going to try to simplify it. Can anybody name something I could do on the left-hand side to start to simplify it? Rudy? Yeah, I think that's a good idea. Let's change cosecant to 1 over sine. And if I'm going to make that a fraction, I'm going to make what's next to it a fraction as well. Only because I'm going to multiply them together. Okay, so this is the left-hand side we're working with. Eric, what do I get when I multiply sine over 1 times 1 over sine?
Sine over sine.
I get sine over sine. Sine over sine. And what's sine over sine? 1. Okay, now we're at the step where you can't change to sines and cosines. You already have that. You don't have two fractions with separate denominators, so you don't even have denominators here. And because you don't have a denominator, you can't use the conjugate trick. So we're out of tricks. There's nearly no more tricks to try. You have to recognize this as something. So if I put up the other page. Does anybody recognize 1 minus cosine squared as having something to do with one of the Pythagorean identities? Yeah? Okay, it's number 1, but is it written exactly the way I wrote number 1? No, it's a rearrangement of identity number 1. So if you take identity number 1 and subtract cosine squared from each side, look what you get. That cancels out, and you get sine squared equals 1 minus cosine squared. So based on rearranging that identity, what did I just say 1 minus cosine squared is? 1 minus cosine squared is sine squared. And what were we supposed to get on the right-hand side of the original problem? Sine squared. And we did. So, if you had to put a reason from this step to this step, this is Pythagorean identity number 1. Okay, the other steps I think people would know. We did a reciprocal identity to start, and then, well, y is sine divided by sine 1. It's just basic division. If you divide two things that are the same, you get 1. Okay, any questions on that? Okay. So let's try this one. It says sine times cotangent plus tangent is going to equal secant. Okay, so for now, we're going to forget about the simpler side. Now, which side is simpler here?
The right side.
The right side. So we're just going to work with the left-hand side and hope that eventually the left-hand side turns into the right-hand side. Okay. One nice thing about the problems that I give you, if it says verify, I'm not lying to you. What's on the left can be turned into what's on the right. Harder identity problems might say verify if possible. So that would mean I'm giving you something to verify. Maybe you can, maybe you can't. Then it becomes a lot harder of a problem. Okay. Oh, Irene, any thoughts what we could do on the left-hand side? I think there's a couple options.
Change cotangent to cosine over sine.
Okay. So since she's going to make cotangent a fraction, I'm going to make the other part of that a fraction as well. Okay. And how about tangent? Anything you want to do with that?
Change it to sine over cosine.
Yep, that's a good idea. Now, because we changed to sine and cosine first, now we have to deal with what's on the outside and use that property. So what property am I going to use next? Yep. I'm going to use distributive. And Alex, can you tell me what I get when I distribute to the first fraction?
Cosine over.
Yeah, what's going to happen is the signs are going to cancel in the first fraction. So all you get is cosine over 1 plus, now do the signs cancel when you distribute to the second fraction? Zach? No, what do you get when you multiply sine times sine? Sine squared. Now, before I even finish, the fact that I see a sine squared here, I'm already starting to think somehow that identity might come up, because that identity has a sine squared in it. But I'm just kind of keeping that in the back of my mind for now. Okay, so we get sine squared over 1 times cosine. Any questions on that? Okay, so does that equal what's on the right-hand side yet? No, then we're not done. Okay. So we use the change to sines and cosines trick. What other tricks do I have we learned yesterday? Two other tricks we learned. Remember about Ryan? Do you remember? No. Do you have it in your notes? Look back at it and see it. I usually wrote like trick in the notes, and then I wrote like, put a box around it or something. So one trick is change to sines and cosines. Last problem from yesterday. Yeah. Okay, multiply by the conjugate. That is another trick we have. We're not ready to do that yet because, I'm not even saying we're going to have to, but we don't have one fraction. So conjugate is when you have all one fraction together. Like, I'll just show you one, I'll jump ahead quick. That's a perfect problem for the conjugate because you have all one fraction and you have one plus or minus a function. So we're going to use conjugate on that one. But what's the other trick besides the conjugate? Yep.
Find the common denominator.
Find the common denominator. Yep. Okay, and can you tell me what the common denominator would be here? Cosine. Now, since the fraction on the right already has it, you don't have to change that fraction at all. So we have sine squared on the right at the top. And now the fraction on the left, what would I multiply top and bottom by to make a common denominator? Cosine. So multiply by cosine, multiply by cosine. And Robin, what's that going to give me in the top? Cosine times cosine.
2 cosine? Or cosine squared?
Cosine squared. Yeah. 2 would be if you added. Okay, so now you have cosine squared plus sine squared. Does anybody recognize cosine squared plus sine squared? What is that, right?
So that's just 1.
Yeah. If you take cosine squared and add it to sine squared, all of that just turns into a 1. It doesn't matter if you do cosine squared plus sine squared or sine squared plus cosine squared. The order is commutative. So that entire numerator turns into 1. And now from here we have a reciprocal identity. What is 1 over cosine? Not sine. Secant. Now we have to go back up and look at the right-hand side. If it's not secant, well then we made a mistake. It is secant. Okay. So we did it correct. Okay, so again, on a verify, I'm not really interested in the answer. I already know the answer, secant. I'm interested in the work. How do you get the answer? Okay, so this one had a few things in it. It had change to sine and cosines, a distributive property, a common denominator, and then the last step was a Pythagorean identity. So it had a lot of different stuff in it. Okay, any questions on that?
Yeah, how did you get to
1 over cosine? So this is Pythagorean identity number 1. And Pythagorean identity number 1 says if you take cosine squared and add sine squared, it always equals 1. Yep. Any other questions on that? Alright, so this one is tangent plus cotangent divided by secant times cosecant. And somehow everything there is going to cancel out. It's all going to just turn into the number 1. I don't think there's any question which side is more complicated, so we're going to work with that side. Okay, Cameron, what could I try first here?
multiplying the bottom part?
Okay, we don't have any formula though that would tell us what secant times cosecant is. We don't. I mean, at least I didn't give you one. There might be one, but I didn't give it to you. So you always want to start with one of your 3 tricks. Okay, you have to pick one of those 3 things. Would the conjugate be a good thing to try here?
Do you have to change to sine and cosine?
Yes, I think we should change to sines and cosines, but just to answer that last question, would the conjugate be a good idea? Would?
Yeah. Like after you get it out, like after you change cosine and sine.
Okay, maybe after we change something, we'll have to come up with another trick to try, but the way it's written right now, would the conjugate be a good idea? No. Conjugate is only used when you have a number plus or minus a trig function. You do not have that here. In fact, you don't have any numbers on the left. So conjugate's not a good idea. Common denominator? Well, common denominator is only used if you have 2 separate fractions. You don't have 2 fractions, at least right now. So the only trick we have left is to change sines and cosines. So we have sine over cosine. Plus cosine over sine. And that's all divided by secant times cosecant. Now, what I'm trying to figure out in my head, just to kind of give you an idea of what my thoughts are as I do a problem like this, I already know that I'm going to get a lot of stuff that cancels in the top. So I'm trying to decide if I should change secant and cosecant to sines and cosines. I think for now, I'm going to leave it as secant and cosecant. I'm not going to change it to sines and cosines. So let's just leave it. I'm not saying it would be wrong to change it to sines and cosines. You could absolutely do it that way. I'm just trying to decide if that way would be better. And based on what I'm thinking right now, I don't think it would be. All right, so we're going to focus on the top. What trick can I use in the top now? It's set up perfect to use this next trick. Common denominator. You've got two fractions with different denominators. Try finding a common denominator, and if you do, something nice is going to happen. Alex, could you tell me what my common denominator would be?
Cosine times sine.
Yep, cosine times sine. So keep the bottom the same. And in the top, common denominator is going to be cosine times sine. And if you really want to make it a fraction over a fraction, you can. Here's your fraction in the bottom. We're going to have a fraction in the top. So now I'm kind of thinking, well, I'm going to be dividing fractions in a second. So now I'm thinking, how do I do that? Okay. But we'll come back to that. Mason, what is this fraction missing so that it would have the common denominator?
Sine.
It's missing a sine in the bottom, so we have to multiply by a sine in the top. Orion, what is the other fraction missing? Well, what's our common denominator for what's in the top? Yeah. Cosine times sine. So that's right there, cosine times sine. That denominator is only sine, so what is it missing? It's missing the cosine. Cosine over cosine. Now, before I do that out, does anybody already see what's going to happen in the next step? Yeah?
It's going to be 1 over cosine times sine.
Yes. You're going to get a Pythagorean identity. Sine times sine. Cosine times cosine. Cosine squared. And as Peter just said, that whole thing in the top is going to turn into a 1. Okay, so now we're going to be getting rid of all the addition and subtraction in the problem, and that's always good. So now all we're going to have left is multiplication and division. So we have 1 over cosine sine over secant cosecant over 1. Technically, if I want to write this properly, I should put the thetas in. I wouldn't take off if you were doing the work and you didn't have them. All right, now leave the bottom the same. just leave it as secant, cosecant. We haven't done anything with the bottom in the whole problem, and I don't think we're ever going to. Just keep leaving it alone. But look at the top. You have 1 over cosine and 1 over sine. Well, just kind of off to the side, if you wanted to think of this, 1 over cosine times sine, it's exactly the same as this. You can separate it into 2 fractions if you want. So you have 1 over cosine and 1 over sine. Okay, think of it separate. What's 1 over cosine? Secant. And what's 1 over sine? Cosecant. And now what happens there? What cancels? Everything. You have a secant in the top, bottom, cosecant, top, bottom. That's why I never change secant and cosecant in the bottom to the whole problem. Because I started to think, as I was even doing the first step, I think it's just going to cancel out at the very end. How did I know that? Again, it's just practice. And that's what we were supposed to get. Okay. But if you were thinking in your head, I'm going to try changing everything to sines and cosines, everything, not just the top, you could have still done it that way. I don't think you would have had, I think you would have had more steps than what we had. Okay. But that's up to you. Okay, any questions on that one? So that was a little bit harder. All right, so this one's going to be kind of the opposite of the last one. This one is going to be very, very easy. It's pretty much going to be 1 step, 2 maybe, depending on what you define as a step. We have cosecant minus 1 times cosecant plus 1. What do you call those 2 things on the left? Cosecant minus 1, cosecant plus 1. Yep. They're conjugates. And what operation are you doing with them? You're multiplying. That's perfect. Anytime you have conjugates and they tell you to multiply them, good things always happen. So let's FOIL it out on the left and see what we get. Okay, Connor, what's cosecant times cosecant?
Cosecant squared.
Cosecant squared. And then Paige, cosecant times plus 1. And then what about cosecant times minus 1? Negative cosecant. And what do you get if you combine the 2 things you just said?
0.
0. Positive cosecant, negative cosecant, gone. And then Molly, what's negative 1 times positive 1? Negative 1. And now at this step, you have to recognize that as something we've written earlier. Does anybody see what cosecant squared minus 1 has to do with? Yep.
That's the second one.
Let's take a look. So if we look at the second Pythagorean identity, that has a cosecant squared and it has a 1. All that this formula does is that. It puts it on the other side. So according to this identity, what does cosecant minus 1 equal? It equals cotangent squared. Let's go back to the problem. And that's exactly what you were supposed to get on the right. problems can be very short, like that one. Okay. Any questions before we look at the last one? Okay, so up till now, I think it's been very clear which side is more complicated. Okay, I've always made it the left. How about here? We have 1 minus sine over cosine on the left equals cosine divided by 1 plus sine on the right. Any thoughts about which side looks more complicated there? Yeah?
The right side.
You think the right side? How come?
Because there's addition in the denominator.
Because there's addition in the denominator? Okay. Well, there's subtraction in the numerator on that side.
It's easier to do if it's in the numerator.
Easier. Okay, how come you think it's easier to do if you have a calculation in the numerator versus denominator? Like if you had this versus this. You think that's easier to do than that?
In these types of problems, usually.
Okay. Any other thoughts? Hey, when I look at it, I'm not really sure which side looks more complicated. Both sides have either a numerator or a denominator that has an operation in it. I don't think addition or subtraction, I don't think one is really that much easier or harder than the other. Both of them use all the same trig functions, and both of them have either a numerator or a denominator with just a single trig function. In fact, in this case, exactly the same trig function, cosine and cosine. So it's up to you. I mean, different people think about it differently, but I think both sides are pretty much the same complexity. Definitely not a problem like this, where it's very clear the left side is more complicated than the right. Okay, I don't think it's as clear in this one. So because of that, you can start with whatever side you want. It doesn't matter. Right? So Cameron, what side do you want to start with?
The left.
Okay, I'm going to start with the left. And we're going to try to turn the left-hand side into the right. Okay, any thoughts about using the trick where we change things to sines and cosines? Why not?
Because there's no, it's already a sine and cosine.
It already is sine and cosine. There's nothing there for a trig function that isn't a sine or a cosine. So we can't do that. How about writing it with a common denominator? Could we do a common denominator here? No, how come?
It's only one fraction.
It's only one fraction. You don't have two fractions to combine. There's already one, and it's already together. So what's the only trick we have left? Yeah?
Multiply by its reciprocal.
Conjugate. Yeah, multiply by the conjugate. Now, usually we do the conjugate of the bottom. Does the bottom have a conjugate here that would really help us do anything? No, it's the top that has the conjugate. You always look for the term that's the number plus or minus the trig function. So Alex, what would the conjugate be here?
1 plus sine.
1 plus sine over 1 plus sine. Now, this type of pattern, okay, the problem I'm giving you right now, that's a pretty common structure for a problem. So after a while, you're going to kind of learn what always happens in this problem. But for now, my hint is don't do out the bottom. Don't distribute cosine to 1 plus sine. Just leave it, because it's not going to matter in a minute. But the top, you should absolutely do out. Anytime you have conjugates that can be multiplied, always do it. So Hayden, if I start here, what's 1 times 1? 1. And then Rudy, 1 times positive sine. Yep. And what about 1 times negative sine? And what do you get if you take the two things you just said, combine them? 0. Okay. Positive sine, negative sine, That's gone. And Faith, what about negative times a positive?
Negative.
Negative. Sine times sine?
Sine squared.
Sine squared, yep. Sine squared. Now, at this point, there's something you need to recognize. Because you can't use sines and cosines, you can't do a common denominator, you already did the conjugate. Okay, we're out of tricks. So, does anybody recognize part of that fraction is something? Yep.
That numerator is part of the first formula.
That numerator is trig identity number 1. So we have 1 minus sine squared. It's a little differently rearranged than what I have there. But what is 1 minus sine squared equal to? Yeah,
Cosine squared.
cosine squared. Okay. 1 minus sine squared turns into cosine squared. And watch what happens there. So we have cosine squared over cosine times 1 plus sine. Now, looking at that, what do the top and bottom both have in common now? Yep, Alex.
Cosine.
Cosine, how many?
1.
There's 2 factors of it in the top, there's 1 factor of it in the bottom, so you can cancel 1 factor from the bottom, 1 factor from the top, and now you're left with cosine over 1 plus sine, which is exactly what you were supposed to get. Had you started with the right-hand side, you would have multiplied top and bottom by 1 minus sine, and it would have turned into the left. So that's that structure. That's a very common type of problem, and you'll probably see one of those on the test. 1 minus something in the top, and then 1 plus something on the other side in the bottom. Kind of thing. But that's it. Any questions on that? All right, so on the homework tonight, they might give you a problem like the one we just had. And they're going to tell you what to do. They're just going to say, multiply top and bottom by 1 plus sine. And that's it. They'll just give you a direction, and all you have to do is do it. You don't actually have to finish the whole problem like we've been doing in class. If you want to practice it, because that's how the test is going to be, you can. But the first, I think, 4 or 5 problems, they give you the problem, they tell you the first step. That's all you have to do. After that, then it's more like the ones we did in class. They don't tell you the first step. You have to figure it out yourself. So the homework, it's on 199 and it goes on to 200. I think 9 to 14 all is where they tell you the first step. And then 19 to 27 odd. Those are more like what we did in class. Okay, you can skip 21 because 21 involves another formula I haven't taught you having to do with even odd identities. Okay, and we don't really study those in this class this week. Okay, so skip 21. Okay, so you've got about 15 minutes. Be good if you get stuck on an identity, I can try to point you in the right direction, especially on those because there's no hints. So feel free to ask me and I'll try to get you started.